Hi, folks. I guess it's, yeah. So hi, folks. My name is John O'Reilly. I'm a software engineer living in Galway in the west of Ireland, working remotely for a company called Neat up in Oslo. And absolute pleasure to be here today in France, or in Paris, talking to you about Kotlin Multiplatform. And what I'm going to talk about today is the combination of Kotlin Multiplatform, GraphQL, and Declarative Ui. So a pretty broad scope of technologies, and it's going to be a bit of a whirlwind tour. But I hope at least, if you haven't come across these before, you'll come away with at least a flavor of what they are, the capabilities they provide, and sort of what I feel at least is a very compelling combination they are together. I'm going to give a couple of slides at the start, just to give some context and overview, and then we'll jump into a live coding session, and that'll give an opportunity as well, as we're adding pieces of code, to add some additional commentary and so forth. And there'll be hopefully time at the end and people have deeper questions. So first up, Kotlin Multiplatform. You may have seen a few talks already about it today. Just again, at a very high level, it's generally about the capability to run Kotlin code natively on a range of platforms. It differs from other approaches, what you might call cross-platform approaches, in that it's sort of really focused in on some sharing of non-UI code. It supports what's described as optional code sharing, which is very critically, from a risk management perspective, allows you to incrementally adopt Kotlin Multiplatform into your existing projects. And some folks have mentioned that already in the previous talk about, well, if this works out, it doesn't work out, but at least you're managing the risk there. It's still something that potentially is consumable on Android, even if you don't go ahead with the multi-platform side of things. And again, you have full access to platform capabilities, and this was, I think this was mentioned as well, illustrated in the async talk earlier by, I think, Dominic, in terms of just being able to access the full cryptographic APIs while still using Kotlin Multiplatform, which I think was very interesting. So this is a quote from Kevin Galligan from TouchLab. If you've looked into Kotlin Multiplatform at all, you're probably very familiar with Kevin and TouchLab, and it's sort of the quote that sort of most succinctly covers, I think, what Kotlin Multiplatform is all about. Covers some of the points from the previous slide, but there was a recent addition to this quote, and JetBrains by Kevin, which really sort of emphasizes very important that this is something that's backed by JetBrains and something that are very heavily invested in. Another sort of thing to point out here, sometimes there's a bit of confusion about KMP versus KMM. So KMP, the Kotlin Multiplatform, is sort of the general capability, to run Kotlin, as I said, on all these various platforms. KMM is a relatively new development. It's sort of, on one hand, is a sort of a rebranding really around the sort of the key use case of sharing code on iOS and Android, along with updated sort of guidance and samples and so forth, and a very nice Android Studio plugin, which we'll sort of see in a moment. GraphQL. So again, GraphQL, probably a little bit hard to describe in a single slide, and again, hopefully as we build out the code later on, if you haven't used it before, hopefully you'll get, as I said, a flavor of what it is. But at its basic level, it's a query language for your API, and of course there's a server component to this. And what's very important in this context then is a GraphQL server provides the capability to query for your schema, and then when you use client libraries like Apollo, like we're using today, you can sort of query for that schema, pull that down, and generate strongly typed client libraries, client code for that. It's sort of seen in some ways as sort of an evolution of REST. Some people have described it, I think, as REST on steroids, but it typically requires less requests, and certainly on a mobile platform, obviously you can imagine what the benefits of doing that. And it's also sometimes sort of referred to as this capability of allowing you to avoid over or under fetching of data, and we'll see a little example of that a little bit later. This is the library we're using today, strongly typed caching GraphQL client for the Jvm, Android, and Kotlin Multiplatform Apollo. The caching aspect of this is important to me. What you're getting as part of this is not just the ability to query your data from your remote server, but caching it locally gives it this very powerful sort of all-in-one capability, and even more so, obviously, when you combine that with being able to run on both Android and iOS. Comes with a very nice Gradle plugin, which we'll see in a moment, for sort of querying the schema and generating the code. And it's in V3 beta. I think the hope is that the version 3 will be released not too distant future. Another very nice thing with GraphQL, if you haven't used it before, is the GraphQL servers typically provide a sort of a playground web UI like this. And this is very handy, and we'll see an example of this in a moment as well, where you can sort of try out your queries, browse the schema, and customize that query, and then potentially pull that in then into your code then. And last in sort of this whirlwind tour is Declarative Ui, Jetpack Compose on Android, SwiftUI on iOS. And folks here, probably a few Android developers, probably familiar with Compose, or at least have seen a lot of the coverage of Compose. But in general, it's described, or it's sort of defined as sort of being this ability to declare what your UI should look like in a particular state. And state is very important in this context. Sort of the idea is that any change in state causes a sort of an optimal relayout of your UI, what's called recomposition in Jetpack Compose. And this is seen as a sort of a contrast to traditional imperative approaches where you sort of more or less describe your UI step by step. A little bit of history. Jetpack Compose was announced at Google I/O in 2019. The stable release July this year. SwiftUI was actually announced a couple of weeks after that at WWDC in 2019. But it was at a much more advanced stage of development at that point. You could download an Xcode beta straight away and try it out. And that's what sort of got me interested in this kind of combination. I had started doing Kotlin Multiplatform in sort of late 2018, and as many Android developers who open Xcode infrequently, would have struggled with view controllers and storyboards and so forth. And SwiftUI immediately came across as this is a very approachable way to doing UI development. And again, that's sort of what I saw as this very compelling combination of declarative UI with Kotlin Multiplatform. And I think that's the experience a lot of people coming into Jetpack Compose are seeing today, that this is, this makes UI development a lot more, as I said, approachable than sort of traditional approaches. The talk today is going to be based on Star Wars repo. I sort of created this repo really sort of focused on talks like this. It's sort of fairly minimal scope, just to allow sort of to manage sort of that in terms of what we're trying to do here. The example in GitHub, not much more sophisticated than what we're going to do today, but it shows the list of people and films. We're going to focus on the list of films. And before, we'll see this in actual code in a moment, but just even at this point in the talk, just to give, if people haven't seen Jetpack Compose before, just to give you again a flavor, this is what sort of Jetpack Compose, this is some code from our sample. And with Jetpack Compose, you declare your UI, or you describe your UI in terms of these Kotlin functions which have this composable annotation. And you pass in some state. In the case of a film list or a film, we pass that in, and we indicate what our UI should be for that state. And this is the equivalent SwiftUI, a little bit different. I mean, we're using structs versus Kotlin functions. Some of the syntax is different, some of the keywords are a little bit different, approach to styling maybe, but fundamentally the same approach. And I'm seeing more and more sort of discussions from people saying, okay, I'm porting this SwiftUI to Compose or vice versa, and it's very powerful, the fact, I think, that we've come to a point in the industry in mobile development that we have UI frameworks now on both iOS and Android that are so similar to each other. This is the Github repo that I mentioned. There's also another one. If you go, I guess, if you are interested and you go to either my Twitter profile, there's a link to GitHub. And I have several Kotlin Multiplatform samples there. This is another one that uses GraphQL. If this is something that's of interest to you and you want to sort of dig deeper, this one has sort of somewhat more complicated UI and also sort of integrates with GraphQL's paging support, and then integrating that with Jetpack Compose's paging support, which is very nice. And lastly, before we jump into code, this is sort of what I guess a high-level architecture diagram for an application like this would be. We obviously have Kotlin Multiplatform shared code. In our example today, we're going to expose a repository. That's obviously interacting with the GraphQL server and some common model. Depending on your architecture, depending on your use case, you may have, if you're using clean architecture, you might have a use case interactor layer here. There's a whole debate about view models. I tend to, in my examples, use the view model in the platform-specific code. There's attempts to use the view model in the shared code, and there's also some very interesting approaches where it sort of straddles the platform-specific and the shared code, where you still take advantage of, for example, Android architecture component on Android, or something that implements observable object on Swift, and you can sort of list in the full sort of platform capabilities in terms of, very importantly in this context, sort of the life cycle, the view life cycle, and still make use of sort of the shared code for sort of view model helper code as well. Okay. So let's start writing some code. Okay. Okay, hopefully this comes through okay. Okay, just before we jump into some of the code, I just want to show, first of all, I guess a common question would be, how do I start a Kotlin Multiplatform project? And there's a few approaches. I think if you have a very specific idea about the libraries you want to use, then there's some good examples out there, some good templates. If you want to start a Kotlin Multiplatform project from scratch, then you can use what I mentioned earlier, this Kotlin Multiplatform plugin that JetBrains provide. And actually, as of 0.3, very recently, there's also a KMM library wizard there as well. If you want to create a standalone Kotlin Multiplatform module, which is a very nice capability to have now. But if you were creating a new project, KMM application, you can go in. You end up with sort of your, specify your Android application, your iOS application, and then there's a range of what's called iOS framework distribution. So ultimately, what you want to do in a Kotlin multi-platform project typically is that your shared code is going to be a jar file on Android, and it's going to be a framework on iOS. And there's a few different approaches. What's described as a regular framework here, or a CocoaPods dependency. And if you go through the library wizard that's here, you also have this nice capability to use XC framework as well. But regardless of the approach you take, you end up in a situation like this where you have a project. This is sort of more or less similar. Obviously we've sort of preloaded this a little bit in terms of some initial dependencies, but you end up with an application with sort of an Android module, some shared module, and an iOS application. And in your shared module, you'll have a Gradle file, which will have uses the multi-platform plugin. We're obviously using GraphQL's plugin here as well. It defines a couple of source sets. Typically, I think a couple of talks earlier have mentioned this as well, the idea of a common main where ideally most of your code will be, and in our example today, all our code will be, in fact, in this common main, but you have the capability then to sort of override that to some extent. You may have seen this expect actual mechanism where you can override that. You can have, in your common code, you can expect a certain class or implementation, and in your platform-specific source set, then your Android-specific or iOS-specific, you can create versions there. Okay, so we're going to start with let me switch over here. So we want to create a GraphQL application here that queries this endpoint and returns obviously the data and renders the data. So the sort of starting point here to some extent is if I go over here, I mentioned that these GraphQL endpoints typically support a playground like this, a sort of a UI where you can sort of try this out. And this is an example here. For example, I'm getting a list of films, and for each film, GraphQL has this concept of fragments, where sort of a reusable chunk, think of it as a class that contains some data that I'm interested in. So we have a film fragment. Right now, we're going to get back let's just run this again here. We're going to get back the ID, title, director. We'll expand that in a moment. Very nice capability here to browse through your schema and sort of customize and tailor your query. So if I copy that query and we go back to Android Studio, that's not Android Studio, sorry. Yes, okay. The first thing actually, before I do that, I'm going to make use of a Gradle task from Apollo, which is going to download the schema from this endpoint. And what we're going to do then is we're going to sorry, now sorry, the text is smaller than. So there's the schema JSON file. This completely describes the schema of the data that we're interested in and the queries that it supports. We're going to create we're going to add in our queries here, and these are the queries that the generated code is going to be based on. And we can actually make use of a nice Android Studio plugin here, which allows us to do a sort of initial sanity test, where we can actually run that query here in Android Studio and see the results that we're getting back. But having done that, having downloaded the schema and having created our queries here, we now call generate Apollo sources, which is one of the tasks that Apollo provides. And this would normally be run as part of your build as well, but we're just sort of running it manually here just to allow us to see the generated code. Okay, so now we have generated code, generated data model, queries associated with our GraphQL interaction. So let's write a repository, a very basic repository. I'm going to make active use of sort of live templates and code snippets here just to not have you watch me mistype a lot of code. So bear with me. And as I said, I'll use that as an opportunity at different points to sort of make some additional commentary. We're going to create a basic repository, and we're going to make use of Apollo's client class here to make the queries. This is the endpoint that we're hitting. I'm also a little bit paranoid in talks like this that the endpoint won't be available. So this project actually has a backend module as well, which simulates this. So this would be the URL, for example, if we were hitting that. And our basic repository is going to have a method to get the list of films. And sorry. Oh yeah, I left out one important part here, which is our data model. Oh yeah, of course, sorry, I thought I had, yeah, absolutely. 16, 17 maybe. Is that better? Is that bigger? It doesn't look like it's a lot bigger. Command Shift 8, you said, is it? Let's see, sorry. Yeah, let's try that. Okay, hopefully that's a little bit bigger. So this is the method that we're exposing from our shared code, primarily, get the list of films. And we're using Apollo client instance that we created to query the list. These are using classes that were auto-generated by Apollo. We're navigating down through our response, which is sort of, the response sort of maps to what we would have seen, for example, in our query, all films, film, for example. And we're providing this method, as I said, it's a suspend function from our repository. And this is going to be the surface area of what our shared code is going to be in our example today. And we're going to add something for iOS as well. And this is going to be a segue to sort of a broader discussion about, yes, okay. So, as sort of alluded to in a couple of previous talks, there's quite a few different approaches to accessing Kotlin code in the shared code from iOS. A very sort of common approach would have been that you provide a callback. So you have something like this where you have a main scope. Very common approach generally also as well is typically the methods in this in your repository are sort of run on the main thread, but they're calling main safe APIs. If you're using Ktor, if you're using various third-party libraries, most of these libraries should at this point are main safe in that you can call them from the main thread. They'll do with context to a background thread, for example. So this example, we're using a main scope here for our iOS client, and we're using a callback. But there's a few different options here, and I think this is very much an evolving area. Kotlin 1.4 added the ability to call suspend functions actually directly from sort of Objective-C and Swift. It comes with some caveats in terms of sort of scope management and cancellation and so forth. And then the other option you have, if I just switch over to, there's a very nice sort of third-party library which I'm starting to use more and more, and I definitely recommend people looking at it. KMP native coroutines. It sort of uses a Kotlin compiler to automatically generate wrapper code for your suspend functions and your flows. And what's not very nice about this is that it supports combine, for example, sort of traditional sort of iOS Swift sort of concurrency libraries like RX Swift and combine. But very interestingly, I think in terms, and I think this is where things are going to go in terms of the usage that more and more people will use this approach, I think, is that with Swift 5.5, the ability was added to this async await mechanism was added and this async stream mechanism. And these map very nicely to obviously suspend functions and flow are very Kotlin specific and, don't sort of translate directly to Swift. But with this capability in Swift 5.5, it now has a capability which can map quite well. And when you're using libraries like this, they make this quite seamless. You can call suspend functions and use sort of Swift's await on it. You can consume a flow, and it maps to an async stream on iOS. So I think that's a very powerful capability, sort of as an aside almost, in terms of where things are going. So if we switch back to our code. The other thing, just to sort of jump back into the shared code build again, I think I mentioned that, okay, so here we're targeting Android, iOS. Obviously, with Kotlin Multiplatform, you can target a wide range of platforms. With KMM, we're typically targeting Android and iOS. But what I would typically often do is add a Jvm Target here. And what this allows me to do, among other things, is you can write a main function like this. And this is sort of an additional sanity test. So if I created a Star Wars repository, I have a method here to get the list of films, and I'm going to print those out. So if I run this here, okay, and it lists out. Just, as I said, it's further sort of bit of sanity test that the plumbing is set up, the classes, the methods, and so forth, and they're working. Okay, so having done that, we have our very sophisticated repository here, which has a method called getFilms. Let's start building out some Jetpack Compose code. So our compose code is typically, as I said, a set of Kotlin functions that have this composable annotation. And you can think of it as almost as a tree of sort of UI components. And at the leaf of the tree, so to speak, we have something representing, if you think of this as a list, obviously, a very common pattern, this is sort of each row in that list. And this represents the film view. And we're going to display the title and director, for example, and we're going to use it's going to be based on this piece of state that's passed in, which is the film. And that film is the class coming from our shared code. And we'll use that same class, by the way, importantly, on iOS in a little while. Let's go up the hierarchy a little bit, and we represent something representing our film list. Yeah. And again, in this case here, we're passing in a list of films. This is the example from the slide earlier as well. We're iterating over that, and we're invoking film view. And this is a good point to sort of just make a comment. You know, as any Android developers here are probably familiar with and doing recycler views and creating view adapters and view holders and XML layouts. This is the sum total in Jetpack Compose of what corresponds to that. So I think that in itself, I think, is very powerful. We'll work our way up the hierarchy, something representing their screen as a whole. We're invoking onto film list here. We're using some Jetpack Compose sort of capability here. We're using the repository directly, so the idea with Jetpack Compose is that these functions can be invoked at any point. So you want to make them as stateless and as free of side effects as possible. Jetpack Compose provides this capability, remember, for example, so that on the first composition, we create the Star Wars repository class. And there's a few different approaches to that. You can, a number of DI frameworks, you can inject view models. There's a range of different approaches to how you might manage the relative life cycle of sort of the classes that you're using. The other thing here is we're using Compose's produce state. So basically, this gives us the ability to map from the state that we're getting from the repository into Compose's concept of state. And state, as I mentioned earlier, is very important. You know, Compose will analyze what's being rendered, and will re-render the appropriate parts of the UI when a particular piece of state is changed. So when we call get films, that film list state is updated, then the film list will be re-rendered. And this is with a relatively basic example with a one-off suspend function. Obviously, a common scenario is where you're using a flow, and Jetpack Compose comes with another range of sort of collect as flow and so forth, other methods that you can do to map again from a sort of flow to the concept of state that Jetpack Compose expects. And so at the top of the tree then is we have a normal Android activity. Instead of using sort of set content with an XML layout as you would have done traditionally in Android, we're using an extension function here which allows us to just sort of invoke our Jetpack Compose code directly. Okay, so let's try and run that. Sorry. Okay, need to switch my target. It's important that one thing goes wrong in this talk just so that you know it's real. Okay, and you get this very sophisticated UI. We'll make the UI a little bit better, just to do a little bit more compose. Instead of invoking sort of film list directly here, we'll use Scaffold, which is a sort of a mechanism or API, I guess, that Jetpack Compose provides to sort of create a UI, sort of screen level UI. So in this case, we're here using the top app bar. In the example in repo, there's a bottom navigation as well. So if we run that. Okay, we get something with a title bar. It looks a little bit better. We'll get back to this in a little while. We're going to, later on in the talk, we'll sort of expand the query a little bit and see sort of the knock-on effects of that and how that works. But before we do that, let's switch over to Xcode. And what we're going to do is something very similar here. I'm going to, again, use sort of iOS code snippets. We're going to pull in a film view, very analogous to sort of the film view element that we showed in our Jetpack Compose code. Instead of sort of row and column as you might use, you're using HStack, VStack, there's text elements. The approach to styling is very different, but this is fundamentally the exact same approach. Something representing our film list. Again, very same concept as what the film list that we added in a little while ago. And just our overall screen again, the content view. And the approach, again, if you haven't seen SwiftUI, syntax a little bit different, the approach to how we show navigation, show the title bar, the sort of this on-appear mechanism, which is SwiftUI specific versus maybe the approach we would have in Compose. Some differences in plumbing there, but from the core UI perspective, it's very similar. Okay. run that. And while that's building, just to mention a couple of things, what's happening under the hood here is that basically, depending on the approach, I showed the Android Studio plugin earlier, and there's different mechanisms by which you can kind of integrate the building of the framework into Xcode. Either as a sort of traditionally it would have been this pack for Xcode, this mechanism, kind of standard Gradle task that you would invoke. With the more recent versions of Swift, Kotlin, there's some additional sort of options there. You can use CocoaPods. There's a variety of different approaches, but fundamentally, what you're aiming to do here is that the shared code is built as a framework and is consumed in your iOS. And this is our UI here, which is obviously very similar to what we have on iOS. Just to switch back to Xcode, the other point I wanted to make here was obviously when we did this, we were delegating out to a Gradle task to build the shared code. If nothing has changed, then the feedback, that is pretty quick. And from a sort of developer ergonomics perspective, I think this is important. The idea is sort of as an iOS developer, and if I'm really sort of focused on creating a sort of compelling user experience, and I have the shared code in the shared module, that build will take a bit longer the first time, but your feedback cycle is very fast after that. It comes back pretty quickly and realizes nothing has changed. There's a whole other discussion in terms of the sort of organizational and sort of logistics in terms of a few different approaches in terms of building the shared code as a binary and publishing that and then consuming as a Swift package, for example. A lot of different approaches. I think one approach is not going to fit all for the industry. I think even within the same team, I think there's going to be some scenarios where you want maybe some subset of your iOS developers to be in a position where they have Gradle, they have everything installed, and they want to be able to modify and build the shared code. Other scenarios where someone is just super focused on the UI and potentially can pull in the shared code as a binary, as a Swift package, for example, which I think is very interesting. Okay, so that's our iOS. Let's switch back to Android again for a moment. And actually, if I go over to my playground here. So we want to expand our query a little bit. So the key part of what I mentioned about GraphQL is that you get these optimized queries. You get exactly what you want. You don't underfetch or overfetch. So we specified that we wanted ID title director. So let's add something a little bit more to that. We'll add the release date. And we can see the release date coming back here. So now let's copy that into, if I can do this properly. If we go back to our query here, we add in the release date. Again, we can use this Android Studio plugin to run the query here into a sanity test. But what we'll do here now is, having changed that, let's rerun the generate Apollo sources here. And having done that now, if I go into Star Wars repository and I look at my film fragment, this is one of the generated classes. You can see, for example, the release date has come back here. And by the way, I didn't mention this before, but part of what you get here is very nice. You get these comments that come in through the schema and are included in the generated code. So let's, having done that now, we can expand our sort of data model to include the release date, update our mapping to map that over. Okay, so now we're exposing the data model, this very sophisticated data model that we're exposing for shared code has been updated and includes the release date. And now I can go into my Jetpack Compose code and say, okay, well, maybe instead of just showing the film title, let's show the title and the release date. Okay, so hopefully if we run this, let me switch back here. Actually, sorry. Okay, and now we have the release date coming through as well. And this is obviously a very simple example, but I'm hoping what comes across is just a couple of different things. I mean, let's just recap a little bit. We have a project here which has shared code, and this is our shared Kotlin Multiplatform code that's going to create a repository that's consumed of both Android and iOS. From this repository right now, we have a simple method to get the list of films, which is going to interact with our GraphQL backend. We have a sort of basic data model that we're exposing and is available then to drive the rendering on iOS and Android, the UI side of things. And then from a UI perspective, everything is very nicely decoupled. You get this very clean separation. We have our sort of shared code that exposes this non-UI functionality, like a repository or some piece of business logic, maybe some analytics, some of your shared storage in your application, for example. And then as a UI developer, then I can consume that through whatever mechanism is appropriate in my particular project or company, and really laser focus then on creating kind of using the full scope of the native capabilities that are available on the different platforms. And that's a very important part of Kotlin Multiplatform, is that you continue to have the full access to the platform capabilities. And I can do that, and I have the access to the shared code, but I can, as I said, focus then on creating a compelling user experience then that uses that code. And that's it. Any questions?